Okay, not all the classes today got to see everything because we had fire drills. Plus, some of these questions are kind of hard, so I did want to look at them a little bit to make sure that the kids that are trying uh, do the best they possibly can with dilations involving perimeter and area. Okay, so number one, we have two shapes here. It tells us we're looking for perimeter, which is what it says here before it got cut off. We're looking for the perimeter of this new shape. So since we're talking about perimeter, we know the formula we're going to use is the new perimeter equals the original perimeter times whatever our scale factor is. Okay. Now it tells us what our original perimeter is. We know this is 38, so we can fill that in right here. Okay, but what we don't have right now is the scale factor. So what we have to look at is the ratio of our sides. So we have sides of 12 to 18. So what we keep talking about is that this ratio actually represents our scale factor. And we just have to think, which ratio is it? So we have either the ratio of 12 to 18, or we have a ratio of 18 to 12. And then we consider, is our shape getting bigger or smaller? And we can see that if it's going from 12 millimeters to 18 millimeters, that it's getting bigger, which means our scale factor has to be more than 1, which means we should have an improper fraction, which means we should have 18 over 12. So this is our scale factor. But, I mean, we could improve on this number. We can say I can divide 18 and 12 by some number, and that some number is either 2 or 3, or most efficiently, we can divide them both by 6. And so that leaves us with a scale factor of 3 over 2. Okay, so we put that in here, 3 over 2. And then this is just like the examples we've been doing. We can rewrite this as a fraction, so 38 over 1 times 3 over 2. We multiply straight across. Once we multiply it, we don't really want to leave our answer as a fraction, so we would then divide it out, and we're going to get some number of millimeters. And I will let you figure out what that some number is. You didn't think I would just give you free answers, right? Okay, so 2 we talked about. We set that one up. If you forgot, set it up just like this one. They're the same, essentially the same problem, just different numbers. Alright, number 3. City of Bryce planning to build a skate park. That's cool of them. Architect designed the area shown to the right. Bam. In the plan, perimeter, the perimeter is 80 inches. So I know that this perimeter is 80 inches. Alright. Now we know the actual length of the park. So there's going to be another park here, so we can draw ourselves a second, more bigger rectangle. And that length of WX, which is this top length here, is going to be 50 feet. Okay. And we want to know what is the perimeter of the actual park. So we want to know the perimeter of this bigger rectangle. Okay, so let's see, where should we start? Let's talk about the perimeter of this guy here. So we know that if this top length is 25 and it's a rectangle, that means this down here has to be 25 as well. And we also know that all 4 sides have to add up to 80. So if we consider the 2 sides we already have, we know 25 plus 25 is 50, right? Plus these other 2 sides, which we don't know yet, has to add up to 80. So 50 plus what number is 80? Well, hopefully you came up with that's just 30. So that doesn't mean that each of these sides is going to be 30. It means both these sides put together has to be 30. So really we got to think, what's half of this? Or what's 30 divided by 2? And that give us side lengths of 15. And we can check it. We can say 15 plus 25 is 40. and 40 plus another 40 down here. That's 80. That's what we wanted, so that's good, right? Check. Okay, so that's the first part. Now we need to know what's our scale factor. And this one, it kind of hopefully stands out to you, even before we did this, that we had 25 and 50. And we say, how do we get from 25 to 50? And we say, well, hopefully, say, oh, well, 25 times 2 is 50. And since it's getting bigger, can we say our scale factor is just equal to 2? Right? And it's not, I mean, we could make it more complicated because this is inches and this is feet. So we could change them around, but we're going to end up with the same thing either way. So we're just going to say our scale factor is 2. So we're going to take all of our numbers and we're just going to multiply them all by 2. So we could say 15 times 2 is 30. 25 times 2, also 50. 15 times 2, also 30. So if we just went based off of the sides we know, if we added all these up and said what's 50 plus 30 plus 50 plus 30, and that would give us 160. Or if we didn't want to add all these up, we have this perimeter and we have a scale factor, so we could use our formula and say that the new perimeter should equal the original perimeter times the scale factor. Or what's 80 times 2? And we get the same thing. And then all we have to remember is, since all these are feet, that our answer would have to be in feet. Guess I did give you one free answer. I'm so nice. Alright, child's desk and a hand. Child's hand. Made. So dimensions are 2/3 dimensions of a full-size adult desk. No adult hand show. Suppose the full-size desk is 54 by 36. Okay, so desktop, that's a rectangle. So let's give ourselves a rectangle here. And then the child's desk is 2/3 that, so it's going to be a little bit smaller. So there's our kid desk. Okay. So our full-size adult desk is 54. Whoops. That's not what I wanted. No, give me a pen. No, not that pen. Yeah, pen. Thank you. Okay, so 54 inches by 36 inches. And we want 2/3 of that. So if it's 2/3, it's getting smaller, so we know our scale factor is just going to be 2/3. Okay. And now, two ways we could do this. One way we could do like we did in class, we could find this area, and we could find this perimeter. Let me just do the math. 54 times 36, and we can do 54 plus 36 plus 54 plus 36. And we could do that. And then we could use our formula and we could multiply it by the scale factor, or the scale factor squared if we were doing area. And we could come up with these here. And that could be fun, but these numbers are kind of big. And I know they're getting smaller. And I think of 54 and 36, and I think these will come out as whole numbers if we just work them out. So what if we just try to change these actual side lengths by 2/3? And can we use our formula for that? Of course we can. Because sides are just like perimeter, they're just lengths. So we can continue using our formula just like we did perimeter. And we just multiply each side by the scale factor. So 54 times 2/3. And then let's see, we actually work this out. 54 times 2, that's 108 over 3, because we just go straight across, right? 108 divided by 3 is some number. That's 3, 9, 16. So guess what? 2/3 of 54 is 36. Hey, 36 is right here. Alright, what if we do the same thing, only now we do it with 36 inches to get this width here. So 36 times 2/3. This is still, let's pick it for color, over 1. 36 times 2, that's 72, divided by 3. We did this one yesterday, so I remember this is 24, because there are 24 hours in one day, and 24 times 3, the number of hours in 3 days, is 72. It's just a fun hourly fact for you. And now we have the dimensions of our new rectangle. And now all we gotta do is think, what is the area and perimeter of this shape? And we do the same thing, length times width, or we add up all the sides. And that'll give you your answer. So that works. There's other ways you can do it too, but you should come up with the same thing. Alright, almost there. Alright, number 5. Theo's got a putting green. Wants it to be similar to the golf course, but 1/3. Area of the putting green of the golf course is this. What will the area be that Theo makes? Okay, so again, excuse me, that was gross. I didn't even say what shape it is, but I'm going to say it's a rectangle, because I can do that. And he wants to make a smaller one. Boop, just like that. And this time, we can't cheat and just do our side links, because all it tells us here is that area of the original was 1134 square feet. And we want to know what is this area. Fortunately, it gives us all the information we need. It says it's 1/3, which means our scale factor is 1/3. And since it's area, we can use our formula for area. So the new area will equal the original area. Original times the scale factor. And remember, since it's feet squared, since it's area, 2 dimensions, this has got to be scale factor to the second power. Okay, then we just put our numbers in. So original is 1134 times 1/3 squared. We remember if we're multiplying or squaring a fraction, it's just the fraction times itself. 1/3 times 1/3. Please don't say it's 1/6. Don't say it's 2/6. That's even worse. This is 1/9. Okay. This is still 1134. We can put this over 1. We're multiplying. I'll do the hard work for you. 1134 times 1 equals 1134. 1 times 9 equals 9. And I'll let you do the easy part. You just divide that and then throw feet squared at the end, and you'll have your answer for this one. Okay, 2 more to go. Making, I think, good time. I think. Okay. This number 6, this is really the reason why I want to do this one, because I forgot to talk about this. This question's kind of terrible, especially if you're honest and don't want to use a calculator, because this is really difficult to do without a calculator because these numbers are kind of big. So Craig's making a model of his neighborhood using trains because Craig's cool. Alright. Right? Model trains. Let's see. Ratio from the model to the actual is 1 to 64. And his neighborhood covers an area of 2,704 square feet. So one thing to notice here is 1 to 64. If we think of that as our scale factor, that's really small. Because really, if you think about it, if you're trying to take your entire town and put it into a square like this, and then you compare it to what you put into your spare room that you do your model trains in, it's going to be like really extra small, right? 1 to 64. And this is actually a scale you'd see for people who do actual modeling, like if you put together like those model cars. I'm pretty sure 1 to 64 is in there, and like 1 to 48 too. Anyways, we know the neighborhood actual area 200,000. That's not the number I wanted. Go back. area 200, 704 feet squared. And we want to know what is this area. So it's the same idea as before, right? New area equals the original area times scale factor squared, where the original is this gigantic number times, and then, okay, we didn't write this down. Okay, 1 to 64, if we write that as a fraction, is 1 over 64, and that's our scale factor. We know it's 1 to 64, not 64 over 1, because our thing is getting much, much, much smaller. Okay, so this would actually be 1 over 64 squared. Okay, now I wouldn't ask you to do this on your own. That would be a big old jerk thing for me to do. So let's actually use a calculator here. 1 over 64 squared. 1 times 1 is 1. You could do that. But 64 squared, 64 times 64, that's 4,096. In case you don't have your chart handy. Right, times 2,704 over, since we want to make it a fraction, it's just over 1. And hopefully we saw this is just like that last example, which I didn't do for you, where everything times 1 is just itself. So really this just works out to a division problem of what's the area of the town divided by 4,096. Okay, these people in the book, they're not nice. But at the same time, excuse me, what I'm thinking, because they might not be nice, but they're not evil, so I'm willing to bet this is going to work out to a nice number. Okay, let's try it out though. So 200,704 divided by, wait, what happened? Oh, I got the wrong number. Okay, hold on. 200,704 divided by 4096. That works out to exactly 49. Yay. So what is the area of his little train? Is 49 square feet. Still pretty big if you think about it. That's a lot of train for like model trains. Okay, that's it. That's number 6. Hopefully you didn't spend a bunch of time doing this by hand. If you did, I'm sorry. And if you show me your work, I'll give you all sorts of extra credit because that's terrible. Okay. All right, then the one on the back. This was not so bad if you actually read it. It says if the scale factor is whatever, what happens to the stuff? Alright, so the scale factor is 2. What do we multiply the length by? Well, if it's just the length, you just multiply it by itself. That's just 2. Width, same thing. Perimeter, same thing. The only one that's going to be different is area, because area is going to be 2 squared, or 4. Okay? And it's the same thing for all these. So let's do, I don't know, let's do 2/3. So 2/3 you'd multiply by to get the length, 2/3 to get the width, 2/3 to get the perimeter, 2/3 to get the area, would be 2/3 squared. So 2 times 2, we did that, that's 4. 3 squared is 9. That's it. Alright, if it's k and you're like, what? K is not even a number. But it doesn't matter. What do we see here? Here's the scale factor, and then all 3 of these are just the scale factor. So if it's k, you'd multiply length by whatever k wants to be. You'd multiply the width by whatever k wants to be. You'd multiply perimeter by whatever k wants to be. And you'd multiply the area by k squared. What's k squared? Who cares? It depends on what k is. K can be anything, but whatever k is, you're going to square it. K? Get it? K? K? Okay. Good night. Have fun. Like, comment, and subscribe. And follow me on the Instagram. Okay, good night.